like balancing. And let's read the question. So we have two blocks connected through 3 different ropes, and then they give you the angle 45 degrees with the ceiling for the second rope, and then they tell you the pieces of information needed for the block A. So block A, they give you the weight, and there's friction on the table, and they only give you static coefficient of friction, which is 0.25. The question asks you to find the maximum weight here for which the system remains in equilibrium. So as the weight of W increases, eventually A will get pulled down, right? So then, but then they also they want the system to be still in equilibrium. So the forces has to be balanced. So if I'm looking at this question, I can just do it by mental math because it's 45 degrees, very special, and I can just do the 3 forces balance. And then I realized because it's 45 degrees, so then if the 3 force had to balance, these 2 forces must be equal. So this is weight, this is the friction essentially, and then which is mu s times the Fg of A. So I can just do mental math and get the result. But then if you're looking at this video, you probably are confused about this question. So I'm going to show you the proper way that IB requires. And which is we're gonna start from the drawing the 3 free body diagrams. So I have 3 free body diagram I already drawn for you here, and then let's look at them now. So one is for the block A, and then the other one is for the weight here, and then but I also need the other free body diagram for this point P, which doesn't have any mass here, but then it's essential to link up the 3 different ropes and the 3 different tension. And the 3 different ropes are not connected. They're 3 different pieces of rope, so they don't have the same tension. So it's very important to separate FT1, FT2, and FT3. And I'm not gonna show you the very correct formatting for IB because that will take too much time. And nobody have the patience to watch, so I'm just going to give you, because the system is in equilibrium, so F net equal to 0, or sigma F equal to 0 for all bodies, all pieces in this question. So let's start from the block A. Remember, up equal to down, left equal to right. So Fn equal to Fga, and then the Ft1 also equal to the static friction. The question asks you the maximum weight at the system. Maximum weight remains in equilibrium, so that means the static friction had to reach its maximum, which is F friction static equal to mu s Fn, then coefficient times the normal force, and normal force also equal to the gravity here. So the conclusion for block A, I have Ft1, tension 1 equals to mu s times Fga. All right, let's change the color. For point P. For point P, one of the force is at an angle. So we need to break it down, this force, and into the 2 components. The parallel component and perpendicular component. And then let's do very basic trigonometry. So Ft2 cosine theta, which is this line, that has to equal to Ft1. And similarly, the upward component for the Ft2, which is Ft2 sine theta, equals to Ft3. Let's just leave it here because the point P tells you only the relationship between the 3 tensions, and then we can move on to the easiest one, which is the weight block. Weight block is only 2 forces, and then it's in balance, so Ft3 equal to W, and doesn't really need too much explanation. So now let's look at them together. So Fga is given. Right, and then mu s is also given. What else is given? They give you theta, right? Theta is 45 degrees because as shown in the diagram. And W is required. So the question doesn't ask you anything about the tensions. So let's try to cancel the tensions out. And so you look at these two equations here. So if I do a division, FT2 will cancel out. So let's divide the second equation by the first equation. 2/1, we get FT2 sine theta over FT2 cosine theta equals to FT3 over FT1. And let's start to cancel things. So FT2 cancels each other. So let's erase this so it can be more clean. And so sine theta over cosine theta, what is that? That's tangent theta, right? Tangent theta equals to FT3 over FT1. But let's try to make some substitution here. So FT3 equal to W, so we substitute here. And FT1 is mu Fg, which substitute also into the equation. So equals to FT3, which is W, FT1 is mu S Fga. And remember, W is the required one. So let's rearrange the equation. W equals to mu S Fga tangent theta. And then we can now just plug in number. Remember, mu S is given at 0.25 at the very beginning. So 0.25, the weight of the block is 6 Newton also given. And then I show the unit, and then tangent 45 degrees. Tangent 45 degrees, we know this is 1, right? So we can ignore it. And then, so 0.25 is 1/4 times 60, mental mass, 15 Newton. And the question is finished. Let's put together so we can see everything at the same time.